Last time we were talking about related rates. And notice that all these application problems were only derivatives. So now we're going to go for more integration applications. So we're going to talk about area between two curves. So what does that look like? Well, I'll show you an example. So if we had this curve and we had that curve, and we wanted to find the area on this interval, I guess, we would have this area between two curves, right? This would be the area between two curves, the area between that. Okay. How do we do that? This is going to be one of those simple videos, but what is the area under this entire function? Let's say this is f of x and g of x on a to b. Note, this is very important. F of x has to be greater than g of x on that interval. They could be equal to each other on the endpoints, but they cannot switchy swatch. F of x has to be bigger than g of x on that interval for this certain thing to work. So, what is the area under f of x? Which I will denote by squiggles this way. Well, it's the integral of a to b of f of x dx, right? What about the area under g of x? That will be denoted by vertical lines. Well, that's the integral from a to b of g of x dx. So how do we find the area between these curves? Well, think about this. That's the area between the curve, right? This is the area under f of x. This is the area on g of x. Well, wouldn't you subtract the area of g of x and you'll get the area between the curves? That's right. All you have to do is subtract the area under g of x. So if we subtract this area, then we'll get just the area between these two curves. So we literally have this formula. So the area between two curves is just f of x minus g of x dx. That's all it is. And you have to have f where this is true on that interval. So f of x has to be greater than g of x on the interval. Okay. Let's do a couple of problems. So we're trying to find the area bounded between f of x and g of x. And those are our functions right here. And now, well, where's our interval from a to b? We don't have one. Well, it says found the area bounded between two functions. Okay. How do we do this? Well, remember I said the function's going to be equal to each other? Yeah. So let's find when they're equal to each other. So our little interval is from 0 to 1 because that's when they're bounded together. That's when they're bounded together. So, wait, is x squared greater than x? Think about that one. From 0 to 1. No. This is actually greater from 0 to 1. Plug in 0.5. Yeah. See? We get 0. What's 0.5 squared? It's 0.25, which is less than 0.5. So this is our upper function, this is our lower function. If I want to look at the graph, this little area right here is from 0 to 1. That area right there. So this is the upper function, this is the lower function. So don't go integral of x squared minus x, go integral of x minus x squared. So the area between bounded by the two curves x and x squared is 0 to 1 of x minus x squared dx. That's the area. So this is going to be x squared over 2 minus x to the third over 3 from 0 to 1. If I plug in 1, we get 1 over 2 minus 1 over 3. Plug in 0, which is 0. So 1 over 2 minus 1 over 3. Well, think about this. This is the same thing as three over 6 minus 2 over 6. 1 over 6, right? So this is the area, 1/6. That is the area between these two curves. And this is really the hardest problem you're going to get. Is you're not going to get an interval, you're going to have to find one that's equal to each other from the bounded curves, right? Then take your integral. That's really it. Let's do one more. And I'm going to change the functions that way. Okay. Square root of x and x squared. Same kind of concept. Let's put x to the third in here. Okay, so we want the area bounded by g of x and f of x, right? So the first thing is, when are they equal to each other? What is the bounded limit? When are they crossed? Well, if we square both sides, note x can't be less than 0, which we're not worried about. because that is not that, right? So what is x equal x to the fourth? That becomes a problem. So we have x to the fourth minus x equals 0. We got x times x to the third minus 1 equals 0. X equals 0. X cubed equals 1. That can only happen on x equals 1. So we still have from 0 to 1, right? From 0 to 1. Which function is greater? Well, first thought is x squared x is less than x to the third. That is your initial kind of thought. And let's plug in 0.5 into that. And we see if that's true or not. If we just plug in a number between 0 and 1. So 0.5. So we get 0.7 for this side. And 0.5 to the third is what? 0.125. So obviously, tides have changed. And, ooh, this is the upper function. And if anyone wants to know what that looks like again, this is what it looks like. This area like that. So now we know we're going to do that the area between, that the area bounded by these two curves is equal to the integral from 0 to 1 of not x cubed minus square root of x, the square root of x minus x to the third dx. This is going to be, 1/2 plus 1 over 2, so this will be 2/3 x to the 3/2 minus 1/4 x to the 4th from 0 to 1. If we plug in 1, we get what? 2/3 minus 1/4. And if we plug in 0, we get 0 minus 0. So remember, this is the same thing as 8 over 12 minus 3 over 12, which is 5 over 12. That is the area, let's see, times 4 times 4 times. So yeah, this is the area under those two, between these two curves. Interesting, right? And these are the only two problems. Remember, the problems are not going to get harder than this. And we can't get really harder because we don't know some integration rules. So, area between the two curves, very easy. Very easy.